March 1941. Mare Island Naval Shipyard, Vallejo, California. The welding torch flickered in the dim light of the submarine construction bay. Edward Ted Nelson, an 11-a-day welder, scrawled his frustration in a worn notebook. There has to be a better way. This is madness. Navy supervisors kept telling him to work faster, but they refused to listen to his solution. He'd just navigated the maze of scaffolding beneath the wooden deck of a submarine under construction. What he'd seen made his blood boil. A dozen workers had spent an entire shift installing a single section of deck planking. Enormous scaffolding filled the interior compartments below each wooden deck. Men hunched with wrenches in cramped spaces, twisting nuts onto bolts that poked down from the deck above. Hours upon hours of labor, just to bolt wooden planks to steel frames. The traditional method demanded precision, patience, and precious time. Time America didn't have as war clouds gathered thick over the Pacific. Yet here, at what would soon be one of the busiest shipyards on Earth, the way they attached decking was exactly the same as it had been for decades. Theodore Edward Nelson, Ted, to everyone who knew him, was 36, born and raised in California. He'd earned his mechanical know-how the hard way, 15 years in machine shops up and down the state, learning how metal bent, how electricity flowed, how problems could be fixed. If only someone would stop and listen. None of the Navy supervisors knew it, but this frustrated welder had already solved their problem, and Ted Nelson didn't know it yet. But his simple idea, rejected and dismissed by his bosses, would soon save the U.S. Navy more than 50 million man-hours. It would fundamentally change naval construction, forever. The standard process, unchanged since World War I, was agonizingly slow. Here's how it worked. First, workers drilled holes through wooden planks at exact intervals. They countersunk those holes so bolt heads would sit flush with the deck. Then they laid the planks on the steel framework below. Then came the worst part, building massive scaffolding inside the submarine's compartments, directly under the deck. Multiple levels of platforms just so workers could reach the underside of the steel frame. Once the scaffolding was up, crews above and below had to coordinate perfectly. Workers on the deck pushed long bolts down through the planks and steel. Workers below, hunched in dark, cramped spaces, twisted nuts onto the bolt ends, tightening them until the planks were secured. Finally, the topside crew filled the countersunk holes with wooden plugs to make the deck smooth. Ted had done this work dozens of times, countless hours standing on scaffolding in submarine compartments barely 4 feet high, twisting nuts onto bolts. His back ached from endless bending, his knuckles were scarred from slipped wrenches, and his patience, it was long gone. But this frustration wasn't just about his own discomfort. Ted could see the bigger picture. War was coming. Every worker at Mare Island knew it. The yard was already behind on submarine construction. The Navy needed boats in the water, not sitting in dry dock waiting for decking to be installed. Every day of delay brought the country closer to a fight it wasn't ready for. And Ted Nelson knew there was a better way. He'd been turning the problem over in his head for months, during the long, routine hours of welding. To him, the solution seemed obvious. Instead of bolting from above and threading nuts from below, why not weld threaded studs directly to the steel framework? Weld from the topside only. No scaffolding, no nuts, no workers stuck in cramped compartments below. Just fast, strong, permanent welds. The concept was simple. A threaded stud, basically a headless bolt, welded to the steel frame in a fraction of a second. The wooden planks would have threaded inserts to screw onto those studs. The whole job could be done from the top. No scaffolding. No below-deck work. No coordination between crews. Ted had seen stud welding before, but only in limited use, on flat horizontal surfaces. The process used loose flux powder. You'd pile it on the steel, set the stud in it, and an electric arc would fuse the stud to the metal. But that only worked on flat surfaces. On vertical or overhead steel, the flux powder would just fall off. And naval construction needed welding at every angle, vertical, horizontal, overhead, any position. This was the problem that had stumped welding engineers for 20 years, how to make stud welding work on non-horizontal surfaces. Ted thought he had the answer. It was so simple he almost laughed when it hit him. Instead of loose flux powder, encase the flux in a small ceramic cap. Glue or clamp it to the end of the stud. The flux stays put no matter the angle. He sketched the idea in his notebook. A handheld welding gun with a spring-loaded plunger to press the stud against steel, an electric trigger to start the arc, and that disposable ceramic flux cap on every stud. The whole operation would take less than a second per stud. One worker could install dozens of studs in the time it took a crew to put in a single bolted connection. He took his sketches to his supervisor, a Navy lieutenant named Morrison. The meeting lasted less than 5 minutes. Morrison barely glanced at the drawings. "We have established procedures, Mr. Nelson. We follow Navy specifications. If you want to weld, stick to your assigned work." Ted tried again, this time with the shipyard's chief welding engineer, a civilian contractor named Hartwell. He laid out the time savings, the labor cuts, the end of scaffolding costs. Hartwell was politer than Morrison, but just as dismissive. "Son, people a lot smarter than you and me have been trying to solve this for 20 years. If it was that easy, someone would have done it already. Besides, Navy specs. We can't change procedures because a welder has an idea. You'd need approval from the Bureau of Ships in Washington. Engineering studies. Prototype testing. That takes years." "We don't have years," Ted protested. "We need submarines now," Hartwell shrugged. "That's not my problem, Mr. Nelson. My job is building boats to spec. Yours is welding." Ted left the meeting angry and disillusioned. He'd offered a solution that could save thousands of hours per submarine, only to be dismissed. Not because the idea was bad, but because he was just a welder. Because paperwork mattered more than progress. Because following protocols mattered more than innovation. He made one last official attempt, a formal letter to the shipyard commander, Captain Thomas Withers. He carefully laid out the inefficiencies, his stud welding solution, and the estimated time and cost savings. He submitted it through proper channels as required for worker suggestions. 3 weeks later, he got a reply, a form letter. It thanked him for his interest, explained that all technical proposals went to the Bureau of Ships Engineering Board, and noted the review process usually took 18 to 24 months. He'd be notified if his idea was approved for further study. He did 24 months. By then, the war could be over or lost. Ted crumpled the letter and tossed it in the waste bin. Captain Harrison must have seen the conflict on his face. "I understand you submitted a proposal to Mare Island in early 1941, Mr. Nelson. I've reviewed that file. Your idea wasn't properly evaluated at the time. That was a mistake, and I apologize on behalf of the Navy. Though, to be fair, your decision to build this independently got it into use faster than any official procurement process ever could. Sometimes the best way to serve your country is to ignore the red tape and just solve the problem." Ted accepted the citation with mixed feelings, pride in what he'd built, vindication for sticking it out, but also frustration at the bureaucracy that had almost buried his idea. The war raged on, and production demands only grew. Ted's company expanded again, opening a second factory in Camden, New Jersey, in March 1943. This East Coast plant supplied shipyards in New York, Philadelphia, Norfolk, and Charleston. By mid-1943, Nelson Specialty Welding employed over 400 workers and brought in roughly $4 million a year in revenue. Ted still worked 16-hour days in the factory, still wore the same tan work pants and shirts. He drew a modest $1,000 a month. All profits went back into expanding the business, buying new equipment, or paying off loans. But his impact on the war effort? It was incalculable. The Navy's 5 million man-hour estimate from late 1942 was just the start. As stud welding became standard across all naval construction, the time savings multiplied exponentially. By 1943, it was used on every type of vessel: submarines, aircraft carriers, battleships, cruisers, destroyers, even small patrol boats. The Essex-class aircraft carriers, built by Newport News and others, used 20,000 Nelson studs each for flight decks and interior fittings. The Navy built 24 of those carriers during the war. Iowa-class battleships used stud welding for decking, equipment mounts, and armor. Baltimore-class cruisers incorporated it everywhere. Every ship, from destroyer escorts to landing craft, got faster, stronger attachments because of Ted's invention. But the most dramatic impact was in submarine construction. Mare Island, where Ted had worked, where his idea had been rejected, became one of the most efficient submarine builders in the world. The yard built 17 subs during the war. with construction times dropping steadily. But Portsmouth Naval Shipyard in New Hampshire was the champion. 79 submarines built between July 1940 and July 1945. Their success relied on many innovations, but stud welding was a critical one. They used TED's system everywhere: decking, interior mounts, pipe supports. The results were historic. On January 27, 1944, Portsmouth launched 3 submarines at once: the Redfish, Ronquil, and Razorback. A fourth, the Scabbardfish, launched the same day. 4 submarines in 24 hours. No shipyard before or since has matched that. At its peak in 1944, Portsmouth built 32 submarines, one every 11 days. The Balao-class subs, which made. Captain Harrison must have seen the conflict on his face. I understand you submitted a proposal to Mare Island in early 1941, Mr. Nelson. I've reviewed that file. Your idea wasn't properly evaluated at the time. That was a mistake, and I apologize on behalf of the Navy. Though, to be fair, your decision to build this independently got it into use faster than any official procurement process ever could. Sometimes the best way to serve your country is to ignore the red tape and just solve the problem. Ted accepted the citation with mixed feelings: pride in what he'd built, vindication for sticking it out, but also frustration at the bureaucracy that had almost buried his idea. The war raged on, and production demands only grew. Ted's company expanded again, opening a second factory in Camden, New Jersey, in March 1943. This East Coast plant supplied shipyards in New York, Philadelphia, Norfolk, and Charleston. By mid-1943, Nelson Specialty Welding employed over 400 workers and brought in roughly $4 million a year in revenue. Ted still worked 16-hour days in the factory, still wore the same tan work pants and shirts. He drew a modest $1,000 a month. All profits went back into expanding the business, buying new equipment, or paying off loans. But his impact on the war effort? It was incalculable. The Navy's 5 million man-hour estimate from late 1942 was just the start. As stud welding became standard across all naval construction, the time savings multiplied exponentially. By 1943, it was used on every type of vessel: submarines, aircraft carriers, battleships, cruisers, destroyers, even small patrol boats. The Essex-class aircraft carriers, built by Newport News and others, used 20,000 Nelson studs each for flight decks and interior fittings. The Navy built 24 of those carriers during the war. Iowa-class battleships used stud welding for decking, equipment mounts, and armor. Baltimore-class cruisers incorporated it everywhere. Every ship, from destroyer escorts to landing craft, got faster, stronger attachments because of Ted's invention. But the most dramatic impact was in submarine construction. Mare Island, where Ted had worked, where his idea had been rejected, became one of the most efficient submarine builders in the world. The yard built 17 subs during the war, with construction times dropping steadily. But Portsmouth Naval Shipyard in New Hampshire was the champion. 79 submarines built between July 1940 and July 1945. Their success relied on many innovations, but stud welding was a critical one. They used Ted's system everywhere: decking, interior mounts, pipe supports. The results were historic. On January 27, 1944, Portsmouth launched 3 submarines at once: the Redfish, Ronquil, and Razorback. A fourth, the Scabbardfish, launched the same day. 4 submarines in 24 hours. No shipyard before or since has matched that. At its peak in 1944, Portsmouth built 32 submarines, one every 11 days. The Balao-class subs, which made. That evening, he made a decision that would change his life and the course of naval history, if the Navy wouldn't listen. He'd build the prototype himself, prove it worked, then they'd have to pay attention. He cleared space in the garage behind his small Vallejo cottage. His wife, Emma, watched with worry as he hauled in scrap steel and welding gear. "Ted, you're going to get fired," she warned. "You're supposed to work on Navy projects, not your own inventions." "This will help the Navy," he said. "They just don't know it yet." Over the next few weeks, working evenings and weekends, Ted built his first prototype stud welding gun. It was crude but functional: a pistol grip, a spring-loaded plunger to hold and press the stud, an electric trigger tied to a welding power supply, and a quick release to load new studs. The most critical part was the flux cap, He tested dozens of ceramic materials, flux mixes, and cap shapes. Finally, he found a design that held the flux tight, let the arc start cleanly, and could be made cheaply. By May 1941, he had a working prototype. He tested it on scrap steel in every possible position, horizontal, vertical, overhead, at every angle. It worked flawlessly. A stud welded in less than a second. The welds were stronger than traditional bolts, and most importantly, no one had to go below the surface to install them. He brought the prototype to work, showed it to a few fellow welders during lunch. They were stunned, excited. "This'll save us so much time," one said. "You should show this to Morrison again," another suggested. Ted shook his head. "I already did." He didn't care. "Then quit," a third welder said. "Start your own company. Sell these guns to shipyards. You'll make a fortune." The idea had never crossed Ted's mind. He was a welder, not a businessman. No capital, no factory, no experience. But the more he thought about it, the more sense it made. If the Navy wouldn't use his invention, maybe private shipyards would. Kaiser in Richmond was hiring. Bethlehem Steel in San Francisco was expanding. Every shipyard up and down the West Coast faced the same labor shortages, the same production crunch. On June 20th, 1941, Ted Nelson handed in his resignation at Mare Island Naval Shipyard. His supervisor, Morrison, tried to talk him out of it. "Nelson, you're a good welder. Don't throw away a steady job for some crazy invention." But Ted's mind was made up. "I'm going to build welding guns," he said. "And when the Navy comes back asking to buy them, I hope you remember this conversation." He left Mare Island with $11 in his pocket, a garage full of tools, and a quiet conviction that his invention would work. On July 1st, 1941, he incorporated the Nelson Specialty Welding Equipment Corporation. He borrowed $95,000 from the Reconstruction Finance Corporation, a government agency set up during the Depression to help small businesses. With that money, he rented a small workshop in Vallejo and started making stud welding guns. The first months were brutal. No customers, no reputation, no way to get his product to market. He made sales calls to local machine shops and small fabricators, demonstrating his gun, explaining the time savings. Most were skeptical. A few agreed to try a demo unit. Slowly, very slowly, orders trickled in. By September 1941, he'd sold 18 welding guns and several thousand flux-capped studs. Then, on December 7th, 1941, everything changed. Pearl Harbor. The Japanese attack destroyed or damaged 8 battleships, 3 cruisers, 3 destroyers, and 188 aircraft. 2,403 Americans died. The United States was at war. Suddenly, shipbuilding wasn't just important. It was a matter of national survival. Within days, the shipbuilding industry exploded into frantic activity. Kaiser Shipyard started building Liberty ships at an unheard-of pace. Mare Island got emergency orders for submarines. Bethlehem Steel and other yards switched to triple shifts, and every single one of these facilities faced the same crisis: how to build ships fast enough. The old methods were too slow, too labor-heavy, too wasteful of precious time. Ted Nelson's phone started ringing. Shipyard purchasing agents who'd dismissed his invention weeks earlier were now begging to place large orders. Kaiser ordered 50 welding guns and 10,000 studs. Bethlehem Steel ordered 40. Even Mare Island Naval Shipyard, where he'd been rebuffed just months before, placed an order for 60 guns and 20,000 studs. His old supervisor, Morrison, handled the requisition. No apology, no admission that Ted had been right. Just a dry official order and a demand for prompt delivery. By January 1942, less than a month after Pearl Harbor, Ted's small workshop couldn't keep up. Orders poured in faster than he could make the guns. He needed a real factory, more workers, better equipment. He leased a larger space in San Leandro, a few miles south of Oakland. The building sat in the middle of a cornfield, isolated, unimpressive, but it had space, power, and room to grow. By March 1942, he had 20 employees. By June, 50. By September, 150. The factory ran 24/7, 365 days a year. Welding guns rolled off the line at 30 a day. Stud production hit thousands per day. Every major West Coast shipyard was now using Nelson equipment, and the reports were extraordinary. A submarine deck that once took 12 workers 6 days to install? Now 3 workers could do it in 1 day. No scaffolding meant 2 more days saved, and workers freed up for other jobs. The welds were stronger than bolts, and the planks were easier to remove and replace for maintenance. At Mare Island, submarine construction sped up dramatically. The yard built 17 submarines between 1941 and 1945, and the average time to build each one kept dropping. As new techniques like stud welding took hold, stud welding wasn't the only innovation, but it was a critical one. By mid-1942, it wasn't just for decking anymore. Workers used it for pipe hangers, cable supports, equipment mounts, bulkhead attachments, anywhere a fastener needed to be fixed to steel. It was faster every single time. The Navy's Bureau of Ships, who'd initially ignored Ted's proposal, now studied his process intensively. Engineering teams tested weld strength, durability, failure points. The results confirmed what Ted had known all along. His welds weren't just faster than old methods. They were stronger, more reliable. On November 19, 1942, just 11 months after leaving his 11-a-day welding job, Ted got an unexpected visit at his San Leandro plant. A delegation of 5 Navy officers in dress uniforms. Captain Harrison, representing the Bureau of Ships, spoke first. "Mr. Nelson, we've completed our evaluation of your stud welding process. We estimate it has saved the U.S. Navy 5 million man-hours in submarine and surface ship construction over the past 10 months. That number will only grow as more shipyards adopt your technology. On behalf of the Secretary of the Navy and the U.S. government, I'm authorized to present you with a citation for exceptional contribution to the war effort." Ted was stunned. They'd rejected his idea, ignored his proposals, forced him to quit and risk everything to prove it worked, and now they were giving him a citation.